All right, today we're going to do a system of equations by elimination. Okay, so let's say we have, as an example, 2x plus 6y equals 26. 3x minus 2y equals negative 5. And we want to solve this system of equations. That would mean find the value of both x and y that makes both equations true at the same time. Okay, so there are more than one way to do this. You could, if you had a accessible, nice graphing utility, you could simply graph the lines and see where they crossed. You could use the substitution method. You can even use matrices and Cramer's rule, which are advanced techniques. But here we're going to use simple substitution, or simple elimination rather. Our goal here is to get either x or y to be opposites, the coefficients of x and y to be opposites. If you'll notice, 2 does not go into 3, but 2 does go into 6. So it would be better to go for the y's here than the x's, because you can multiply the bottom equation by 3 and not worry about the top equation and achieve opposites. So let me show you what I mean. So we multiply the bottom equation by 3. We'd have 3 times 3, that's 9x. 3 times negative 2, that's negative 6y. 3 times negative 5 is negative 15. If I do nothing at all to the top equation, I'd have 2x plus 6y is equal to 26. And notice that we have opposites now in front of y. Okay, so I can go ahead and add these together. 2 plus 9 is 11. The y's cancel. 26 minus 15 is 11. Okay, we add the equations together here, which is perfectly legal because I'm adding equals to equals. Okay, these two things are equal to each other. So if I add them to two things which are also equal to each other, the equality is preserved. Naturally, here we divide by 11 to get x equals 1. Now we need to know x and y, so we go back to the original equations. You can go to any equation that has x and y in it, but generally the original equations are the easiest. I'm going to put 1 in for x. I'm going to do it for the top equation here, this equation. Okay, so I'm going to say 2, not x this time, but 1. 2 times 1 plus 6y is equal to 26. 2 times 1 is 2. Now we solve naturally for y. Subtract 2 from both sides, so 6y is equal to 24. Divide both sides by 6. All right, and then you get y equals 4. So x is 1 and y is 4. We're going to present our answer like an ordered pair. Regardless of the order in which you found the variables, you do want to present x first and then y. So that's important. And you can check this by putting 1 and 4 back in here and making sure that both equations are true. So solving systems by elimination.